Imagine a time when our universe was compressed into a point smaller than an atom. 13.8 billion years ago, this point expanded in a cataclysmic event, the Big Bang. This wasn't an explosion but an expansion of space itself, marking the beginning of time and the universe. From this singularity, the universe began to cool and expand rapidly. In the first fraction of a second, the fundamental forces of nature began to separate. The universe was a maelstrom of energy, a place of unimaginable heat and density. Yet within this chaos lay the potential for everything we know and are yet to discover. The story of the universe is a story of transformation from a state of unimaginable density and heat to the vast and complex cosmos we see today. The early universe was a hot, dense soup of elementary particles. Imagine a cosmic cauldron filled with quarks, leptons, and bosons, all colliding at unimaginable speeds. These particles, the building blocks of matter, interacted in a frenetic dance. As the universe expanded, it cooled, allowing for the formation of more complex structures. Protons and neutrons began to form from the primordial soup of quarks. These protons and neutrons would eventually come together to form the first atoms. The universe was still too hot and energetic for stars or galaxies to form. The journey from this hot, dense soup to the structured universe we observe today is a testament to the power of the fundamental forces of nature. It showcases the elegant dance of cosmic evolution. As the universe continued to expand and cool, a pivotal transition occurred, the formation of atoms. Around 380,000 years after the Big Bang, the temperature had dropped sufficiently for protons and neutrons to capture electrons. This capture led to the formation of the first atoms, primarily hydrogen and helium. This era, known as recombination, marked a significant change in the universe's properties. With the formation of atoms, the universe became transparent, allowing light to travel across space. This freed light, initially released as high-energy gamma rays, has been stretched and cooled over billions of years, observed today as the cosmic microwave background radiation. The formation of atoms paved the way for the formation of stars, galaxies, and eventually our own solar system and planet. It marked the transition from a universe dominated by radiation to one where matter took center stage. The cosmic microwave background, CMB radiation, is a faint afterglow of the Big Bang, a thermal echo that permeates the universe. Discovered in 1964, the CMB provides a snapshot of the universe as it was a mere 380,000 years after the Big Bang. The CMB appears as a faint glow across the sky, almost uniform in every direction. Tiny temperature fluctuations within the CMB reflect the seeds of the large-scale structures we observe today: galaxies, galaxy clusters, and cosmic voids. These fluctuations represent regions of slightly higher or lower density in the early universe. Over billions of years, gravity amplified these tiny differences, pulling matter together to form the cosmic web of galaxies and clusters we see today. The CMB is a testament to the Big Bang theory, providing compelling evidence for a universe that was once much hotter and denser. It is a window into the universe's infancy, allowing us to study the processes that shape the cosmos. After the release of the cosmic microwave background, the universe entered a period known as the Dark Ages. During this time, the universe was filled with neutral hydrogen and helium gas, and no stars or galaxies existed to illuminate the darkness. Gravity gradually pulled together regions of slightly higher density, causing them to collapse under their own weight. As these regions contracted, they heated up, eventually reaching temperatures high enough to ignite nuclear fusion in their cores. Thus, the first stars were born. These early stars, much more massive and short-lived than our Sun, flooded the universe with intense ultraviolet radiation. This radiation ionized the surrounding neutral hydrogen, a process known as reionization, which cleared the fog and made the universe transparent to ultraviolet light once again. The first stars grouped together to form the first galaxies, which over billions of years collided and merged, shaping the universe into the tapestry of light we observe today. About 9 billion years after the Big Bang, a giant molecular cloud in the Milky Way galaxy began to collapse under its own gravity. This collapse led to the formation of a protoplanetary disk surrounding a young, forming star, our Sun. Within this disk, dust grains clumped together, forming larger bodies. These planetesimals collided and accreted, eventually forming the planets we know today. Closer to the Sun, rocky planets like Earth formed, while farther out, gas giants like Jupiter and Saturn accreted vast amounts of gas and ice. Earth formed in the habitable zone of our solar system, where conditions were just right for liquid water to exist on its surface. The formation of the solar system and Earth is a story of cosmic recycling, with atoms forged in the hearts of long-dead stars brought together by gravity to create our cosmic cradle. This simple molecule, essential for life as we know it, played a crucial role in the subsequent evolution of our planet. The early Earth was a harsh and unforgiving place, bombarded by asteroids and comets, with a toxic atmosphere and volcanic eruptions reshaping its surface. Yet, in this primordial soup, life emerged. The first life forms were simple, single-celled organisms likely resembling bacteria or archaea. These early life forms thrived in Earth's early oceans, using energy from sunlight or chemical reactions to survive and reproduce. Over billions of years, life evolved and diversified, eventually giving rise to more complex organisms. The evolution of photosynthesis, the process by which organisms use sunlight to convert carbon dioxide and water into energy, was a pivotal event in Earth's history. Photosynthesis released oxygen as a byproduct, gradually transforming Earth's atmosphere from one rich in carbon dioxide to one rich in oxygen. This oxygen-rich atmosphere paved the way for the evolution of more complex life forms, including, eventually, us. The ultimate fate of the universe remains one of the most profound questions in cosmology, with several competing theories offering different possibilities. 3 potential scenarios stand out: the Big Freeze, the Big Crunch, and the Big Rip. The Big Freeze posits that the universe will continue to expand and cool indefinitely. As the universe expands, galaxies will drift farther apart, star formation will cease, and eventually, even black holes will evaporate, leaving behind a cold, dark, and empty universe. The Big Crunch proposes a contrasting scenario. If the universe's expansion were to slow down and reverse due to gravity, the universe would contract, eventually collapsing in on itself in a fiery inferno. This scenario suggests the possibility of a cyclical universe, with the Big Crunch potentially leading to another Big Bang. The Big Rip presents a more dramatic end. If the expansion of the universe continues to accelerate at an ever-increasing rate, driven by dark energy, the fabric of space-time itself could be torn apart. While the ultimate fate of the universe remains uncertain, each scenario highlights the vastness of cosmological time and the incredible forces that govern the universe's evolution. From the Big Bang to the intricate dance of galaxies, the story of the universe is one of awe-inspiring scale and breathtaking beauty. It humbles us, reminding us of our place in the grand scheme of things, yet also fills us with a sense of wonder and a thirst for exploration. The atoms in our bodies were forged in the hearts of stars. The molecules that make up our world were born in the crucibles of supernova explosions. We are, in a very real sense, children of the cosmos, products of billions of years of cosmic evolution. As we continue to explore the universe, we are not just unraveling the secrets of the cosmos, but also discovering more about ourselves and our origins. The universe is a vast and mysterious place, full of wonders yet to be discovered. As we look up at the night sky, let us be reminded of the incredible journey that brought us here, and the infinite possibilities that lie ahead.